All right, what's going on, guys? This one's about bit flags or integer flags. You can call them either one. It doesn't really matter. Let's zoom in here again, so you guys see. So this is the code from the last video. Again, so I'm not going to delete this code. I'm just going to comment it out like I always do. Comment it out. We're going to write the new code here. Okay, so what's a bit flag? So a bit flag is, what's an integer flag? So an integer flag is you have a piece of code that accepts, seem to accept only one parameter as a flag, and that parameter is an integer. But technically speaking, you can pass in, well, you only pass in the integer, but that integer flag can somehow contain a lot of information, and up to, technically speaking, up to 32 Boolean values could be put inside one integer. And how is that possible? So it's possible through bit manipulation. So to understand how it works, you need to understand how bits work. I'm going to quickly go over how it works. But if you want to learn more about bit operations, I guess I'd recommend another YouTube tutorial, or simply go on Stack Overflow and learn about how bitwise operations work in Java. So in Java, integers have 32 bits, so they're represented this way. So I'm not going to type in all of them, but you get the point. So let's say each one of them is an integer. Is a bit. So how would a bit flag work? So let's start off with this. What's the bit representation of 0? You guessed it, it's 32 zeros. Okay, there's 30 of them. I'm not going to type in 32. But what's the bit representation of 2? It's, again, you guessed it, it's this. This is 2. What's the bit representation of 4? You guessed it. It is, I'm not going to do all of them, but you get the point. So 8 is basically switches this bit to 1. 16 switches this bit to 1. 32 switches this bit to 1. So on and so forth. So as you can see, each increment of the power of 2 flips 1 bit to 1. And technically speaking, a Boolean value is simply that. It's a bit switch, right? 0 could be considered false, and then 1 is true. So with that logic, I can technically inject 32 Boolean fields into a 32-bit integer. How do I do that? We do it through an OR operand. So if I have a bit, so value here, let's say flag, right? And then I'm statically given these 2 fields. Actually, you know what? Let's just start coding. I'm going to create our packages like we always do. Call it bit flag. Okay. I'm going to call it let's go flag manager. Basically, all it's going to do is accept a bit flag and then do stuff with it, right? Bit flag manager. Okay. So this has flags such as private static final int flag 1 20 0. So one thing to keep in mind though, they have to be power of 2s. Otherwise, you can't do 1, you can't do 3, you can't do 5, because those flip multiple bits. So they have to, the number you're passing in needs to, its bit representation needs to flip 1 bit and 1 bit only. And then for this reason, you can only use 0, 2, 4, 8, 16, 32, 64. You get the deal. I'm just gonna have one more. The more the better, right? These are my flags, and then I have privates. Integer. Well, so we want to eventually turn them into booleans, right? Because the only method, the way it works is that we pass an integer flag, one that is in the form of one integer, and then we extract booleans out of it. So let's name these something else. Let's say is cool. Okay, is cool flag is old. I don't know. Doesn't matter. Is heavy. Coming up with random objective right now. Is green. Actually, just gonna call it cool, heavy, and then green, and then what else? Long. Okay, and then now I can use booleans here in my code. Cool. I'm gonna call it cool. Boolean is old. Boolean is heavy. Private boolean is green. Private boolean is long. Okay. Well, I made a mistake here. These need to be public. Okay. And then my method here will have public set flags. Flag. And I'm going to have getter methods for these. Okay, I got them generated. Okay, cool. Yeah, so let's go back to our main because I need to explain how it works, right? So, like I said, it works through OR operand, so which is this. So, I have to cover how OR operation works. I mean, how operand works on integers, otherwise it won't make sense. So let's say if you do 2 or 4, so which is if you do 2 or 4. So what's the value of 2 or 4? Let's look. So this is 2. This is bit representation of 2. This is bit representation of 4. So each bit, it goes one bit by bit, basically gets ORed with the same bit of the other integer, and the result gets written into the result integer. So here, in this case, first, let's look at the first one. It's basically 1 or 0. 1 or 0 is what? As you can see, is 1. 0 or 1 is again 1. And the rest will be 0 because 0 or 0 is 0. Okay. 2 or 4 here. Okay. So you see, since I'm only using numbers that flip 1 bit and 1 bit only, like I said here, 2, 4, and I'm gonna write down 8 here also. See, they only flip 1 bit and 1 bit only. That's why the OR operation works. Because if you OR any 2 of them, or even all of them, they will only flip the bit and the result integer. Each one of them will only flip a unique bit in the result integer. So this flag will flip the first bit when you do an OR operation. With any other one, because the rest of the numbers will have 0 in their bits. And the flag that's tagged with 4 will flip the second bit to 1. 8 will flip the third bit to 1. If you do OR. So each flag that gets ORed will flip their own bit that we use to represent them in the result integer to 1. So the result integer will end up being that. The value of the result integer doesn't matter. It will be some random value that won't give you any kind of benefit, but it doesn't matter. The bits will contain the information you need. So let's go over it again. Since the representation of 2, the bit representation of 2 is just flipping the first bit to 1, and 4 is flipping the second bit to 1. 8 is the third bit to 1. If you OR them, you can see 2 or 4 ends up giving you this bit representation. See? And if you OR 8, if you do 2 or 4 or 8, you don't actually lose anything. It's exactly the same. The only difference will be now the third bit will also get flipped to 1, because that's what represents 8. So this will be your result integer in the flag. So you can do this. I mean, you can just do a system out println on this to see what the flag is. The value of the flag, integer value of the flag, does not matter one bit at all. But the bit representation does matter. Okay, so we now know how bit flags get set, but how do we extract the value out of it, right? Because that's very important. Again, with the same logic. Since I know if the integer value, the bit representation of my result flag, which in this case is this, would have the bits I'm looking for flipped. So how do I get that out of it? Easy. It's using an AND operation. So if I do, in this case, flag, let's say I'm looking for Boolean flag of 0, right? I'm gonna call it, not 0, is 2. Meaning is 2 as a value inside my flag. It works in a kind of weird manner, but you get it. Flag and 2. Yeah. Okay. This is how it works. So this is my bit representation of my result value. So if I do this and 2, again, how does an AND operation work? It works by comparing each bit of both integers, and then do an AND operation in between, and then put the result bit in the result integer. And then, yeah. So let's just do an example. I'm going to move this down here so we can understand better. And I'm going to move this over up here so we can match. So 1 and 1. The result is what? Let's do it together. 1 and 1. The result is obviously 1. And 0 and 1. What is the result? Obviously 0. Because 1 is true, 0 is false. True and false in logically speaking, is what? True and false is false. For an operation to create a result true, both logical expressions needs to be true. And since 1s are true and 0s are false, in this case it will generate 0. Again, for the third bit, 0 and 1. The result is 0. And 0 and 0, and the rest will be, again, don't even need to do it, is 0. So what do I see here? Do you see? I hope you see the pattern here right now. Because if you do, if I use this, my result integer that I get from doing an OR operation in all my flags, if I AND that with the flag that I'm looking for, I get the value of the actual flag. See? I got the value of 2, right? So to convert that into the Boolean flag, all I have to do is check if it equals to the flag that I ANDed with. So this logic right here, flag and 2 equals 2, will result in the Boolean that I'm looking for, meaning whether it gives me the answer to whether that flag has been set or not. So how does that compare here? I believe here it will make more sense because we actually gave names to the flags, and you'll see how it works. So when I set a flag, I'm going to basically try to extract all of this out of this flag. Here's how. This is cool equals flag and cool equals cool. See? Okay, so I created all getters, all the setter, well, not setters, I set all my flags here. As you can see, this is how you extract the flags that you pass in. So to see if it works, I'm going to create a test. Okay, so let's press this. Which name convention did I use here? Okay. Okay, so flag manager, green. Oh, you know what? Doesn't matter. Flag manager. So it's going to be cold, cool, and green, just like Grinch. Okay, this is how you send the flags. And then assert flag manager is going to be is green, it should be true. Assert flag manager is cool, it should also be true. And then assert false flag manager, all other flags should not have been set. It's heavy. I feel like I'm missing one. Old. Okay. Okay. Let's run it. Yep, test pass. So our code works, our flags work, you can manipulate it, and then play around, see what you can do with it. But let me explain why it's beneficial. It's beneficial because the only other way to achieve this kind of behavior would be, this only works obviously with Boolean flags because you can only put a Boolean inside an integer, right? That's like I said, because you have to just basically utilize the bit operation, but yes, that's what you won't accept anything else. Just you can only put Boolean values in an integer. So why is it beneficial? It's because otherwise you would have to have 5 setter methods for this flag, or your whole method, set flag method, would have to accept 5 Booleans. You might be thinking, hey, but I'm doing bitwise operations here. Bitwise operations are super cheap, extremely fast. So like it has no performance overhead if that's what you're worried about. This works exactly as fast as setting the flag directly. But obviously, to me, the way I see this is a lot less verbose and a lot more clean. It allows for a super clean API, as you can see here. Well, you can see clearly in the test. Look how cool is this. Otherwise, you would have to pass a bunch of Boolean fields, which may or may not be, which may have like 30. It's just like a Boolean version of builders, right? It allows you to pass in the flags that you want and nothing else, using just one flag and one flag only. Android operating system and Android SDK really utilizes flags a lot. And then I'm sure if you're an Android developer, you've seen a lot of these in the SDK code base and an API that's exposed to developers. So yeah, I hope you like it, and then see you in the next video.